Hello, and welcome to this Institute of Physics CPD session, where we'll be looking at how we can represent forces using force arrows. I'm Daisy Fox, and I'm a physics coach with the Institute of Physics. This is the second instalment of this series on forces, and we hope you have the opportunity to explore the other two videos as well. Typically, we would get students to represent forces with arrows. And this is particularly important because naturally in real life, we can't really see forces. All we can really see is the effect they have on objects and their interaction with different things. And arrows are really good to help us represent forces because they can tell us three key pieces of information. The first thing they can tell us is about the strength of the force. So a small arrow would represent a small force and a larger arrow would represent a larger one. The second thing they can tell us is the direction of the force. So whether the force is acting to the right or whether the force is acting to the left. And finally, they can tell us the point where the force acts. And this is particularly important because when students sort of meet this topic in, at age 11 for the first time, this is the bit that they sort of often fall down on. They get the idea that a large force, large arrow, force right, let's point it in that rightwards direction. But the point at which the force acts is sort of one of our initial misconceptions that we can see. So if we switch to the visualizer for a moment, you can see on the page that I've got the image of a skydiver. And one of the things that we might typically get the students to do is think about just the downward force in this case acting on the skydiver. And they might draw some little arrows like this. Because at this point, we might not really have spoken to them about the concept of centre of mass. So they haven't really got the idea that we can represent a force just using the one arrow acting through the centre of mass of our objects. And because of that, one of the other things that we can sometimes see is that, yes, they might have the idea that we can just use the one arrow, but they might draw it all the way over here. Okay, so it's that downwards arrow, it's acting in the downwards direction, but it's not really anchored to our skydiver. We can't really tell that it's acting on her. One of the other things that we can find as well is that students are aware of kind of this gravitational force. They've met it before, they know that it's the force that keeps them on the ground, but they've got that preconception that it's actually a force that's pushing down on them. So sometimes we can see them drawing that gravitational force arrow acting from above instead of pulling our skydiver down. So when we are discussing force arrows for the first time with our students, one of the things that we want to be quite clear on is that the forces are always acting on something. So the tail of the arrow must always be anchored on the object that we're talking about. So in the example here, you can see that in the first diagram, we've got the force arrow acting through the centre of mass of an object. And in the third diagram, we've got that force arrow acting at the point where that force is acting. The two blue arrows, sort of in the second and fourth diagram, you can see that those arrows are sort of floating around, and that's really not what we want to see when we're considering the physics of this. But one of the things that I find teachers say to me straight away when I sort of show them this diagram is they'll pull out a textbook and straight away sort of say, oh, look, but in the textbook it's got this picture with the forces floating around and not really anchored on the object. And there's a reason for that, and it's relatively valid. And that's that, if you're a publisher and you're thinking about the image and the diagram that you're showing, sometimes having lots of force arrows, like especially on a small object, can make the diagram look a bit busy and cluttered, and this is something we'll look at later on, in this video when we look at examples of using force arrows. One of the other constraints as well, especially when it comes to exam boards, is that exam papers are typically printed in black and white, so it makes it difficult to use colour to distinguish those different types of force arrows. However, for us as teachers and educators, we really want to think about how we're representing those forces and how we're talking about the physics. So we really do want to make sure that when we're building these scaffolds to encourage students to think about the type of force and where it's acting, that we really are promoting this idea that the tail of the arrow is anchored onto something. One of the ways that we can get students to experiment with this, sort of for the first time in a really non-threatening way, is to perhaps have a series of diagrams or objects around the room and use cardboard arrows, such as this one, to represent the forces, that they can directly stick onto an image or onto an object. And the great thing about these is that you can print them in different sizes, different colours, and obviously if a student gets it wrong, it's not something that's permanent in their book. If you turn around and sort of say, oh, think about it, is it really acting there? They can just move this cardboard arrow along instead of having something permanent that they've then got to cross out and sort of fiddle around with a little bit. Another example of this, if you don't have cardboard arrows, is just to use mini whiteboard. And again, it's not something permanent that's gone in their book. They can just rub it out and redraw the diagram to get it right. So just a couple of ideas there about how you can introduce this to your students in a really non-threatening way. But really, in those first few examples, what we would perhaps look to do is to start getting students to think about where these forces are acting. And as a general rule of thumb, we would say that where you've got a contact force, such as something being pulled along by a rope or friction acting on an object, that you would draw those arrows at the point of application or where the surfaces meet. And then when you've got a non-contact force, such as the gravitational force, you can show those acting through the centre of mass. So that's a good rule of thumb to try and have. Now, what we really want to be trying to do is to develop a forces model that we can use with our students that really helpfully and easily gets them to identify which forces are acting on an object and where they're acting. And one of the things that we sort of typically struggle with in our day-to-day situations is that actually our real life situations are complicated with many objects in the sort of situation. It sort of comes back to what we were talking about before, with our floating arrows going around in textbooks and sort of exam questions and things like that, because we do like to use images. We do like to use photographs such as this one, or we might even have the students in a room, where we're getting them to think about the forces acting on objects. So I've chosen a child sitting on a chair as the example to use here, because certainly in my experience, what I've found is that this is a really equipment light way to get students thinking about forces for the first time, and in particular get them to start thinking about what forces are acting on them. So I might typically say to a class of 11-year-olds, right, you're sat on the stool at the bench, what forces are acting on you right now? So what I'd like you to do is just pause the video, perhaps for about 30 or 40 seconds now, and just think about, if you were to turn around to your students and ask them to identify the types of forces acting on the child, or if it was in your classroom and you were getting them to think about the forces acting on themselves, what types of forces would the students offer up? And when you come back, what we will do is share with you just a sort of a Mentimeter survey when we ask this question to teachers, just to see the types of things that those teachers offer back. Okay, so we've seen that our students can make situations perhaps a little bit more complex than they need to be. My favourite answer I ever got offered at this point was the skeletal forces of the child. The students really thinking about the sort of, the fact that without a skeleton she would collapse into a monkey, well, not a monkey, it's like a big blob. So what we want to encourage our students to do is to kind of take one of these complex situations and try and simplify it. So the first thing that we would ask them to do is to identify the object that we want to focus on. So in this case, it's the child. Then what we want to encourage them to do is to isolate that object. So take out all the sort of background, everything like that. We just want to focus on the child. And how I've done this in the video is just to isolate that object and remove all that background clutter from the image. And what that enables us to do then is to just think about those forces acting on the object. In this case, it's the child. And now I can quite clearly see that there must be that gravitational force of the earth acting on the child. And I think, well, why isn't she just falling indefinitely? Well, there must be a support force, and that's being provided by the chair, and that's acting on her in the upwards direction. Now, There's a few points to discuss around this diagram. The first thing that you'll probably note, it's probably the most obvious thing on the page, is that I've sort of assigned the different types of forces different colours. And I make a point with this with the students because it helps when we're building up to ideas, especially about Newton's third law, sort of later on in the topic. Because with Newton's third law, we're talking about this idea that the type of force has to be the same. And so if we make the types of forces different colours, we can clearly see here that we don't have a Newton's third law situation because the types of forces are different. And making them different colours really, really makes that stand out. So I would, I would assign forces different colours, and then I stick with it as well. So I make sure that in the lessons that I'm teaching, we sort of always make sure that that gravitational force of the Earth is always that sort of that orangey reddy colour, and any support forces acting upwards are always a yellowy colour. One of the other things that you probably notice, and again we've sort of spoken about this before, is that my force arrows overlap each other in terms of their position. You know, we've done this deliberately because we want to show that that gravitational force is a non-contact force, so it's acting through the centre of mass of the child. And we want to show that the support force of the chair is acting at the point where the child is sat on it. So it's acting at the point where those two objects meet. What that means is that I've kind of got this slightly messy diagram where it's not perhaps that clear that those forces are sort of equal in size, which is represented by, you know, the arrows being equal in length. So one of the things we want to think about next is how we can kind of tidy this diagram up a bit and sort of make those things a bit clearer. So where we would progress to with this would then be to start thinking about a free body diagram. And here we have got rid of the child and we've represented her with a pink blob. And we're sort of limited by kind of what we can demonstrate with PowerPoint here. But typically what you'd want your students to do is really to show that as a dot. And doing that means that we can now change the diagram that we had before, and we can show that force of gravity acting downwards and the force of the chair acting upwards. And hopefully now what it's a lot clearer to see is that those forces are equal in size and they're acting in opposite directions. And so we've got our child in equilibrium on the chair. One of the other things that we'll perhaps notice is the way that I've written the, sort of the description of what the forces are at the moment. And that's particularly important, that instead of just giving them labels such as support force, normal contact force, gravitational force, weight, and kind of things like that, I'm really encouraging the students here to think about, you know, the force, what it's acting on. And again, that helps us get rid of any misconceptions that students might have, and it helps with the scaffolding when we're trying to get them to explain what's going on. So once we've got them to think about identifying the forces, we want them to then build up to these sort of 4 sentences. And these 4 sentences are really, really useful because we are probing the student's understanding on what kind of force it is that's acting on the object, what's providing the force, and what is the force acting on. And this is a really, really useful exercise to get students to do, because one of the things that we can find students do quite often is that they will label forces that aren't there. So a classic example of this is thinking about hitting a tennis ball over a net. When that ball is in mid-flight and it's left the racket, there's an assumption that there's still a force acting on that ball, driving it over the net or driving it in its flight. And so if we can ask these kinds of questions, like, so what kind of force is it? A student might turn around and say, oh, it's the push from the tennis racket. You're saying, well, what's providing the force? It's the tennis racket. But then you can probe and sort of say, well, when the ball's in midair, is the tennis racket still providing that force? And they go, oh, no. So when they realise that there's nothing providing the force, they realise that that force can't be there. So actually, there's no driving force once it's left the tennis racket. These sort of prompts and these things that we use to scaffold these 4 sentences can be really, really useful to get the students to identify what's really happening in a situation. And it enables them to construct these types of phrases, the force of the acting on the whatever it's acting on. And if we just look at an example of this now, so the example that we're going to use is a hockey player hitting a hockey ball. It enables us to describe what's happening in the situation a lot more clearly. So we can talk about the push force of the hockey stick acts on the ball. What I probably encourage you to do now is to perhaps go away and think about some of the examples that you use with the students in your own classes and think about how these 4 sentences might look. Thank you very much for watching this second video. I hope you've enjoyed it and found something useful either in your own teaching or for supporting the colleagues in your department.